So this lesson's a lot like our last lesson. This time, though, we are focusing on ASA. Last time it was SSS and SAS. So today we're going to add on to it. We're going to add in ASA, angle, side, angle. So by the end of class, you'll be able to explain angle, side, angle, and use it to prove triangles are congruent. You need to know it because proofs are a huge part of what we're doing in geometry, especially in this unit. And then bigger than that, proofs just deepen your logical thinking and sequential thinking. And you'll know you have it when you can determine when you have what you need so you can apply ASA. So a lot like what we did last time, we're going to start with a construction. We're going to take two angles and the side in between. So we're going to copy two angles. So let's first copy this blue angle onto the point right here. So copy an angle, you stretch it out, you make your arc. And then we want that same exact arc on the point where we're trying to copy it to. So then we're going to measure the opening of that angle from one intersection to the other and duplicate it on our copy. And then draw the other side of that angle. So we've got the angle. We need the other angle, but we also need the included side. So we're going to do the side next. Go in order. Angle, side, and then angle. So here's the side we need to copy. That long right there. So we're going to bring down, we're going to mark that down here on the line that we've got. So right now we know that this angle is congruent to that angle. This side is congruent to that side. That's the way we designed it. That's the way we constructed it. So now we're going to copy that other angle. So we have the angle, we've got the side. We're going to put the other angle right here at this red point I just created. So you make your arc first, and then make the same arc over here from the point. And then since it's going to be a triangle, it's going to have to come into the inside like this. You can measure how wide that opening is, and then duplicate it. Whoops, wrong spot. So our angle now goes from that red point through this green X. That's our angle. So our side has to go through. And now we've got our triangle. It's right here. I'll highlight it. So we're going to do the same thing on this other line. We're going to try to make it different. Last time I did blue angle on the left and green angle on the right. We'll switch that around. So let's do the green angle over here on the right. Try to make it different. So we've got that arc. And then measure the opening. It's not writing. Right? There. So we've got our angle. Draw the line in there. We also need that side length. We're going to copy the red side. So that's how long the red side is. And then from that red point I just created, we're now going to copy the blue angle. So you make your arc, copy that arc. It has to go through that little X. So draw the line and then we're done. Because that made a triangle. So there's our triangle. And looking at them, it may or may not look like they're congruent, but you can match them up and you can see pretty good that they are. So since those two triangles were the exact same, we get a name. Angle side angle congruence criterion. Angle, side, angle, ASA. Since the side has to be between the two angles, when you write it, S goes between A and A. The side goes between the two angles when you write it. All right. Are the two triangles congruent with given BD is an angle bisector of ABC and CDA? So, you know, there's a few things we can get from the picture, but there's also, in this case, a couple of given statements. So, BD is an angle bisector, cuts the angles in half for both angle ABC. Let's look at that one first. Here's angle ABC, and it says it's cut in half right there. Bisected, cut in half. Since it's bisected, that means these two angles are the exact same. And then same thing on the other side, CDA. Since that angle is bisected, it means those two angles are the exact same. But we got to mark them different, so we do the two arcs. So that's two pieces of information. All of those side, 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 angle, all of them require three. They're all three letters long. So we need one more thing. Can we get one more thing from the picture? So we're trying to prove this triangle is congruent to that triangle. And when you trace them out like that, I think it's pretty easy to see that we did the same side twice. They both have D. And it's obviously congruent to itself. That's called the reflexive property from last lesson. So now we've got, in our yellow highlighted triangle, we've got an angle, another angle, and the side in between. In our green highlighted triangle, we've got an angle, another angle, and the side that's in between them. So yes, we have angle, side, angle. Two angles with the side in between. We had the two given statements and then the reflexive property. Are the triangles congruent given IO's perpendicular to LN? IO, LN. Perpendicular, makes right angles. And we're trying to show the two triangles are congruent. So let's highlight them again. We got the yellow triangle and the green triangle. When I highlighted this side twice. So now we've got each triangle, we've got a right angle in each triangle. We've got IO is in each triangle. That's two things. And that's it. That's it. We only have two things. So there's a follow-up question here. What would we need to know to make those triangles congruent by angle, side, angle? So right here, we don't have enough information. Trying to do angle, side, angle. We've got the side. That's marked right there in purple. We got the side. We got the angle on the one side of it. So we need the angle on the other side of it. The angle on the other side would be those two. So we would need to know that angle LIO Remember, I always goes in the middle. Wherever the angle is, that letter goes in the middle. And we got to name the other angle, again with I in the middle, because that's where it goes, in corresponding order. Since we started with L on this triangle, we got to start with N, because those would match up. It would just be like a reflection. N-I-O. So now we're going to do another proof, a full proof, writing it out, all the statements, all the reasons. So when you're doing a proof, I always start and suggest that you start by marking up your triangles before you do anything else. Angle S and angle U are right angles. We can make that marking. Angle S, angle U, they're both right angles. We're also going to know that those are congruent, because all right angles are congruent. They're all 90, so they're all the same. And then RV bisects SU. Only one of those is getting cut in half, because it doesn't say they bisect each other. Only one of them is getting cut in half. RV bisects. That means RV is doing the cutting. SU is the one getting cut. SU is the one getting cut, so that means these two sides are the same. And you always look for more information. Reflexive, vertical angles, that sort of stuff. In this, we've got an X intersection, which is vertical angles. Those two angles are congruent. So now that we've got the triangle marked up, we can choose which three-letter property, side, 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 SSS, side, angle, side, SAS, or angle, side, angle, ASA. We can choose which of those matches up for these triangles. So we've got two angles. We've got the side in between. That's going to be ASA. So what I suggest with your proofs when you're doing these, we know what it's going to be. So we're going to do a little organization. We're going to write angle, side, angle. And we're going to write what the two angles are and what the side is that we know. And maybe even make a little note to ourselves as to why we know it. You can abbreviate it all, but A stands for angle, so we know an angle. We know angle U is congruent to angle S. That's the angle that we marked. You're just looking at your picture now. Angle U is congruent to angle S. And then the reason for that, we'll just keep it in our head. We don't need to write it down, but angle U is congruent to angle S because they were right angles, and all right angles are congruent. It said they were right angles, so that's given, and all right angles are congruent because they're all 90 degrees. Then we've got our side. The side that we marked up right here was UT is congruent to ST. We got that from these markings right here. We got those markings because it said RV bisects SU. And bisect means cut in half. So that's the definition of bisect. And bisect was given. And then our third angle, the third piece of information, it's right here, these blue marks. We can't just say angle T because they're both angle T. You have to do the three letters. Could be VTU or UTV. It doesn't matter. I'm going to go UTV. So since I went U first, that's the right angle. On the other one, I got to start with that same corresponding letter. U corresponds with S. Then we go to angle T, and then to R. And we knew that because of vertical angles. So we need to say these three things before we say angle, side, angle. So we start with the given. Angle S and angle U are right angles. We're also told RV bisects SU, so we can kind of combine that into one statement. But the first thing you write is always the given. And from that, since they were right angles, that told us that they were congruent. Because all right angles were congruent. And then since they bisect, RV bisects SU, that told us that those two sides were congruent. That's the definition of bisect. So we took care of each of these things just in the order that we wrote them. So we got the third one here. And then the reason we knew that that was there, it wasn't from the given, it was from the picture, because they were vertical angles, and that's our reason. So once you make those three statements, the three statements right here, that is everything you need so that you can say angle, side, angle. Whenever you say angle, side, angle, or side, 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 or side, angle, side, any of those things, you're saying two triangles are congruent. Just like that. You're saying RST is congruent to triangle VUT. And our reason, we already have it written down there also, is angle, side, angle. That's the entire proof.